Hi everyone, my name is Rajan Kumar, CEO founder of Ateios Systems. We're using solvent-free electrode manufacturing using radiation curable polymers. Next slide. So everything in your life that has a button requires a battery. Your phone, your car, all the electronics around you. Unfortunately, these devices and the batteries that power them are facing rising prices and limited supply. In fact, it is forecasted in 2022, the battery shortage will double the current microchip shortage. And what's more important is that the US will face both economic and security challenges because of this, as only 1% of batteries are manufactured in the US. This is happening because of lack of innovation in manufacturing. The current process of manufacturing batteries has remained unchanged since the 1980s. It is a process that is slow, toxic, expensive, and limiting in design. And using that technology, it will take 30 years to meet the global demand of energy storage. Next slide. The primary problem lies in the curing of key battery components. So the image on the left shows how batteries are manufactured today. These process of taking these inks coated, and they go through these long thermal runners to remove unwanted toxic solvents. At Ateios, we have the solution. We have patented a process that uses light instead of heat. You can see in our process on the right, we're able to shrink this to less than 10 meters, reducing the cost significantly. We have proven this process can manufacture those key components 10 times faster, 5 times cheaper, without toxic solvents, and without compromising performance. And what's really exciting is that our process is so rapid and versatile, the design applications are limitless. And if you were to outfit every existing gigafactory with our technology, it would only take 2 years to meet that global demand. Next slide. So what's compelling about our technology is that it's chemistry agnostic. So it can be adaptable to any type of size and battery, thereby giving our company the opportunity to impact the global battery market of over $120 billion. And we're already doing this, providing batteries for small, powerful wearable sensor valued at $300 million markets. And we're going to scale the technology to impact electric vehicles and grid storage valued over $50 billion. Next slide. And so that's why I'm really excited to announce we've actually released our first battery product, Intercom. It's a high energy density battery using our process and is getting significant traction as a power supply for wearables and sensor. You can see right here, one of our batteries already. Oops, upside down. So this battery has 50% more energy per area. It's optimized for wireless communication, which impacts over 95% of IoT devices. And what's exciting, it can be robotically mounted, enabling our customers to move from 2 minutes a year to over 200. Next slide. We're already currently producing batteries for leading manufacturers in diabetic monitoring, digital shelving displays for retail display. This market has blown up because of inability to hire. So you have these displays that automatically update pricing instead of having someone do it manually. And then asset tracking for shipping companies. And we see on average, our customers are looking to purchase over 12 million units per year, an average selling price about less than $1. And we're able to generate at a margin of 35%. And just give you context of why our customers are buying. This right here is a asset tracking patch that goes onto a FedEx box. Right here is a competitor battery that takes up 90% of the device. With this product here, Intercom, it reduces the area by 2x, but we have 4 times more energy density compared to them. And that's why our customers are buying. And this is why our company is now on pace to generate over $10 million by the end of 2022. Next slide. And not only is our technology process really exciting, we have a very effective sales strategy to promote growth and scale. So our innovation is in how we manufacture the components. We do it faster, cheaper, with better performance. So essentially, we build these components as a roll of films, full production scale. And then we already work with established assemblers in the space where they will simply die cut for each customer spec. We have software that allows us to build your own battery on your website and then spit it out directly so an OEM can integrate. This is where we're using that to generate leads automatically. Next slide. And the main thing we've been successful, I have over 10 to 20 years experience in semiconductor and print electronics, was the inventor of the world's first printed stretchable battery. And then my colleague, Carlos Menez, our CEO, is doing other novel research work on blood replicants as well. And the reason why we've been so effective and so efficient with our funds with only $1 million is because we're flipping the batteries startup model. Instead of raising significant funds and building up own facilities, we are incubated in a $15 million pilot facility. We have access to all this equipment so we can be nimble, but have the pilot scales to validate quality, supply chain, and pricing. And this is why customers are paying significant NRE for us to get these products in their hands. Next slide. So what we're here today is we have many customers right now that are asking for samples and requesting for quotes. We actually have a purchase order for this product of over 20,000 units. We're opening a bridge round to help us scale up to 1 million units per month at this average selling point, increase our marketing so we can bring in more customers in the pipeline, and bring in a senior VP of manufacturing to help scale up the process. Thank you. Any questions? You can go next slide. All my contact info, everything is there available.
Awesome. Let's go by the order. Samira, you first.
Yeah, thank you for the presentation. How much does it cost you to create those batteries? And I'm also curious about the material you're using in those batteries.
Yeah, so I say this chemistry here, from what I remember, the pricing, we're selling this at 50 cents, and our price is roughly less than 30. And
what kind of materials are you using?
So the chemistry that in this product we have here is what is called lithium CFX. This is proven to have the highest energy density for primary batteries, or 800 milliamp hour. It was previously plagued with high price and then poor power. We were able to optimize that with our process.
And I don't know if you're probably aware of the scarcity of the materials, right? And such as lithium as well. Yep. So is that something have you guys thought about it? And because we are running out of those minerals. I mean, there is a data we're done, right? So the only other way would be getting it out of the, smartphones or whatever is right out there. So have you guys thought about, Yeah,
it's a good question. We haven't really dived too much into it, but we are finding ways to make it in line with our company goals. For example, because the price of CFX is pretty high traditionally, it's used in drones and power tools. We've actually found a way to reduce the cost by 5 to 10x through an upcycling process where we take someone's waste material and then modify it into useful, and they pay us to take it. So that's one way is we're trying to, kind of fix that supply chain, but also reduce our costs at the same time.
Thank you.
Hi, Raj. I'm Mark Krasinski with the General Dynamics Mission Systems. Do you have any environmental limitations as far as where the batteries can be deployed and operate? High temperature, low temperature, underwater, altitude, things like that?
So I'd say for the chemistry that I hold here, it doesn't have a solid state. It's just a liquid electrolyte. So yes, it would have limitations on those environments, but we just did get funded by Army SBIR to start hardening it for military use. We are incorporating a solid state electrolyte from a well-established company to make it extreme and tested for military use applications.
Very good, thank you.
Anna, you're up.
So can you talk a little bit about the performance compared to other lithium-ion performance? Because this is something that there's so many chemistry out there, right? Are you competing mainly from the form factor standpoint, that this is very thin, but what about the lifetime and things like it, the cycle performances and things like that?
Yeah, so I'd say like inherently we're focusing on the manufacturing process. So we're not looking to do any new traditional materials. We're just bringing them into our process, and we manufacture faster and cheaper. That's the first initial. But we are finding with the process, we can improve battery performance. Like through our NSF SBR, we did a head-to-head comparison with this battery with our process versus traditional, and we found a 10% increase in performance on both the power and energy. And then also in rechargeable, we're seeing that for silicon anodes, those get really high energy, but you need a really high, what is called a thick cathode in order to get the really high watt hour per liter. Our process can do double the thickness compared to traditional manufacturing. So we're seeing a lot of opportunity to improve battery performance as well right now.
Great presentation. I'm really interested about your tech. I'm actually meeting with my battery team
Mhm.
tomorrow. I'm with Mitsubishi Chemical. So we do the electrolytes for the Panasonic batteries.
Right. Okay.
We do silicon anodes and cathodes, and we're looking at all sorts of different approaches. And this is interesting because we have just now looking at different processes. So my question on you is there any limitation on your process regarding materials? So anode, cathode, any type of special exotic materials that are being used now on some of the batteries? Is there a limitation on what you can do there? And the second question is, are you going to scale up to larger battery form factors on your own? Because I know you're doing obviously wearable small battery systems, but are you looking at doing it for EV and other vehicles? In other words, increasing your capacity and building bigger battery systems.
Yeah, so I'll answer the first question. Yeah, right now we see there's like different polymers that can be used for e-beam curing process that we use. One are water-based, one are solvent. So basically you have a wide spectrum of selection materials that you can use depending on the materials you have. So we can make that adjustment, and we have a patent from Oak Ridge on that process. So we can, and what's really cool is we have software where you tell us all those specs and we can properly optimize the battery design. So that's one powerful tool we have, that combination of hardware and software. For the second question, yeah, our ultimate goal is to impact EVs and grid storage. What I see as a challenge is everyone wants to move EV, but we don't have the bandwidth manufacturing to hit that demand. It's just not physically possible with the current manufacturing. And yeah, we could build more factories like we're doing right now with silicon, with semiconductor manufacturing, but we need to innovate. And this is the technology to do it. But we find, many battery companies, they raise $200 million and they try to go for EVs and grid. And that's a really hard product to build. 10-year lifetimes, huge battery price. It's just a waste of material. And it's just eats R&D money. So we said, look, if we can validate the process and build something small, generate revenue, that revenue we're just going to throw that right back into R&D and build up, just expand the battery size into pack and just do a more robust testing and scale up. So you can see the vision from doing small batteries, just making many of them for IoT and sensors, just sell them really quick, get them out of space. Then you do drone size, power tools. Maybe they don't have to last 10 years, but you could do 3, get some good revenue. And then you jump to EVs when you've got data. I mean, I talked to some battery companies here, like SL, they're just now having their 15-year testing on their EV batteries, and they're already promising warranty, and they're now getting the data. So we want to make sure we validate and scale the technology, be responsible with the money that we get from investors.
Just curious if you're looking at also any innovation around recycling of battery materials.
Yeah, we're interested. I mean, our goal right now is to be really focused on the manufacturing and validate that process. We are looking for ways to look at new chemistries to recycle. We have one of our investors, Heritage Group. It's a very large billion-dollar consortium. Their expertise is in recycling. So that partnership is going to allow us to take advantage of that.
Great. Thank you.